Okay, so here is, oops, sorry. So in this video, we're going to do some examples of one-to-one functions. And we're going to show, hey, how do we determine whether a given function is a one-to-one function or not? So again, first of all, we have to be dealing with a function. So all of these are functions that I'm going to show you, because if they're not functions, they cannot be one-to-one anyway. Okay, so we're going to determine which of these functions are one-to-one and which ones aren't. Okay, so let's start with C. I'm going to start with C first. Okay, so here is a function, and you can see that it's a function because each x only goes to one y. So -2 only goes to 2, right? You don't see any other -2. So there's no duplicates of the first coordinate, right? So we don't see two different x values going to the same y value, right? Or excuse me, I'm sorry. We don't see the same x value going to two different y values. That's what I meant to say. So we don't see anything being repeated as far as the x coordinates, okay? So this is a function. Now, what we want to see is if it's one-to-one, then we should not have what? The same y value corresponding to two different x values. Okay, so do we see any, or in other words, do we see any two different x values going to the same y value? For example, so let me draw a picture real quick. So let's say this is the domain, and this is the range, and we've got x1, x2, x3, we got y1, y2, y3, and so an example of a function would be this, right? We could have x1 going to y1, x2 going to y2, and we can have x3 going to y2. So this is a valid function, right? This is a valid function because each and every x value only has one y value, right? x2 only goes to y2, x3 only goes to y2, x1 only goes to y1. So as a function goes, we can have two different x values going to one y value, and that's okay, it's still a function, but it's not a one-to-one function, right? Because a one-to-one function says that for every y value, there's only one x value. So in this case here, this y value is from two different x values. So it's not one-to-one. Now, if I wanted to make this into a one-to-one function, well, in this case, to make this a one-to-one function, I would have to do that. And so one-to-one functions always have one arrow going from one x to one y, one x to one y. 1x to 1y. So one-to-one functions always look like this, okay? So when we go to F here, what are we looking for? We're looking for no repeats in the y variable. So we should see no repeated y coordinates. If there are no repeated y coordinates, then it's a one-to-one function. Okay? Because in a one-to-one function, we know we're not going to get any repeated x values, else it wouldn't be a function, right? But in this case, we want to make sure that there's no repeated y values. So in this case, there are no repeated y values, y coordinates, and so this is a one-to-one function. Okay? So now let's do A. Okay, so how do we determine whether A is a function? Well, here's how we prove it. What we're going to do is remember the definition. The definition, I'm just going to write this down and then I'm going to erase it. But the definition says if A not equal to B, so if we take two values in the domain, A not equal to B, if this implies this, then F is 1 to 1. Okay? So guess what? We're going to use that definition. So we're going to use the definition of one-to-oneness to prove whether these are one-to-one functions or not. So let's do that. Okay. So what I'm going to do is I'm going to choose two values in the domain. So I'm going to choose two values. Now, since this is a polynomial function, it's a linear function, so the domain is all real numbers. So I'm just going to pick two arbitrary numbers that are not equal to each other. Like, for example, A and B, right? So let's say, let's assume, right? Let's assume A is not equal to B. Let's start with that, okay? So we can do that. We can say given A is not equal to B, let's see if we get f of A cannot be equal to f of B. So let's say. So let's do f of A. What's f of A? F of A equals negative 4A plus 12. Right? F of B is equal to negative 4B minus 12. Right? Okay. So, if we use the definition, one way we can do that is, and I meant to mention this, I didn't mention this all together, so let me go back to the definition. So we're saying, if A is not equal to B, implies, so we're saying, hold on, sorry. Let me start over. So we're saying A not equal to B implies, f of A is not equal to f of B. Okay, now what we're going to do, so actually we're not going to assume this, we're going to go the other way. So this is the definition, right? So if this is true for any A and B in the domain, then we know that it's 1 to 1. But there's also what we call the contrapositive, which means if we go the other direction, so that means, which would be equivalent, is, hey, if f of A is equal to f of B, that will imply that A must equal B. So that's the easier way of doing it. Okay? So instead of using this definition here, we're going to use what's called the contrapositive, which means we're going to go the other direction and we're going to negate both sides. Again, you don't need to know that, but what we're going to use is this to prove one-to-oneness. Okay, so we're going to start with this because this is easier. If we start with the assumption that they're both the same, so let's start with A equal to B, or excuse me, f of A equal to f of B. So we're going to start with f of A equals f of B. And then what we're going to do is we're going to say, hey, if these are equal, if we start with the assumption these are equal, and that leads us that A must equal B, that's the same thing. This, proving this, is the same thing as proving this, right? Because if we show that, hey, if we assume these are the same, and that leads us to the conclusion that A must equal B, then we're done. Then they have to be one-to-one. Okay? So, let's do that. Okay, so now we've got f of A and f of B, and what we're going to do is we're going to set these equal to each other. So that means negative 4A plus 12 equals negative 4B plus 12. And now all we're going to do is simplify. Well, if I subtract 12 from both sides, that's going to get rid of both 12s. And I'm going to end up with negative 4A equals negative 4B. And then, of course, if I divide both sides by negative 4, I get A equals B, and I'm done. So by using the definition of one-to-oneness, or a one-to-one function, we just prove that this function, negative 4x plus 12, is one-to-one. Okay? Now, let's check for B. Okay, so far we have C is one-to-one, and we know that A is one-to-one. So let's find out if the function B is one-to-one. Okay. So now, let's see what we get here. So we're going to start with, again, we're going to assume for any two values, A and B, we're going to assume that f of A equals f of B. Which means we're going to say that the square root of 25 minus A squared is equal to the square root of 25 minus B squared. And so now what I'm going to do is I'm going to square both sides, right? If I square both sides, I get rid of the square roots, right, using the square root property. And then what I'm going to do is rewrite this, and I'm going to get 25 minus A squared equals 25 minus B squared. So far, so good, right? Now, I'm going to subtract 25 from both sides. And that gets rid of the 25s. And so now what do I have is I have negative A squared equals negative B squared. And now I can multiply both sides by negative 1 and get rid of the negative sign, so that's easy. This is going to lead us to A squared equals B squared. And then what do I need to do to both sides? Well, I need to just take the square root of both sides, right? I'm trying to get to see if A is equal to B, right? So I need to get rid of these squares. So the only way I know how to do it is to take the square root of both sides. And if I do that, what do I get? Well, if I take the square root of both sides, I get A. Now here's where you got to be careful, because we're dealing with square roots. Remember the definition of the square root, or even roots. It has to be equal to plus or minus b, right? Because we're not told whether b is positive or whether b or a is positive, right? All we're told is there any number in the domain, and let's think about this, okay? Can x be negative in this case? Well, yes, it could be negative, because if you take the negative x and square it, you get positive. So guess what? The domain of this function is all real numbers, because x can be negative, or x can be positive, or x can be 0, and it doesn't cause any problems because you'll never get a negative under the radical. So any value of x is fine. So a and b could be negative. So in this case, we have to be careful. We have to add the plus minus in here. Okay? So that means that a and b are not necessarily equal all the time. So this function is not a one-to-one function. Okay. Does that make sense? I hope that makes sense. Okay. Again, practice these. Do more of the book and just do more problems. You can find them and practice, and just make sure you can use the definition of one-to-oneness to prove whether something has a one-to-one function or not. And this is the way you do it. Or if you have an ordered pairs, if you have ordered pairs, a set of ordered pairs like this, then it's very simple. You're just looking to make sure that there's no repeated values of the y-coordinate. Okay? And that's it. Have a great day.